All right, this first page is about perpendicular bisectors, and something kind of neat happens when you take a triangle and you draw the perpendicular bisectors on each side of the triangle. So first, let's review what is a perpendicular bisector. By the way, you should use pencil, but I'm a trained professional, so I'm going to try using pen. Up in this picture, I've already got perpendicular bisectors drawn. You know what perpendicular means, right? It means that those are intersecting those sides at nice right angles once you draw that in. But that's just the perpendicular part. The bisector means that those are hitting at the midpoint, and that means that this piece and this piece are the same length. So let's draw that in for each of these three perpendicular bisectors, showing how it's perpendicular to each side and it bisects each side, meaning those two pieces are congruent. Finally, this bottom one is perpendicular and it's bisecting this side into two congruent pieces. I don't know if you realize how amazing this is, but when you draw the three perpendicular bisectors, they all happen to meet at one point. You might even call it the center of the triangle. They call that the point of concurrency. To concur means to agree, and so all three of those perpendicular bisectors agree on that one certain point. And for perpendicular bisectors, we don't just call it the center of the triangle, we call it the circumcenter. So that point of concurrency is called the circumcenter. And here's just a drawing of that circumcenter without all of the perpendicular bisectors. There's actually a really amazing property besides the fact that all of those intersect at one single point, which is amazing enough. If you measure from each vertex to that circumcenter, it turns out that those three lengths are the same. Another way to say that is that the circumcenter is equidistant to the three vertices of the triangle. And that actually allows us to draw a circle where the center is at the circumcenter, because since each of these is the same length, we could use that as the radius of the circle. So why don't you just try sketching a circle that would have its center at that circumcenter. We could use our compass, but this is such a small picture. And again, the reason that we could do that is because of this equidistant. It means that that can be the radius of our circle. And they say that that circle is circumscribed about the triangle, and I suppose that's why they call this the circumcenter, because it's the center of that circle. We're going to do our own measurements on this picture. So remember, to find a perpendicular bisector, we need to find the midpoint so that it actually gets bisected, and we'll need to make it perpendicular. So let's write that out. So we'll use our ruler to find the midpoint. Let's do this bottom side first. I'm going to use the centimeter side just because it's a little easier to divide by 2 when you're not dealing with the fractions that you do in inches. So I'm seeing that this is about 9.4 centimeters. I'm going to write that down here. 9.4 centimeters. And if I wanted to find the midpoint, I'm just going to take 9.4 divided by 2. That tells me that I will put my midpoint at the 4.7 mark. So here's 4, 4.5, 4.7. You're using a pencil because if you make any mistakes, you'll want to fix those. So we've got our midpoint right there. If you'd like to mark a tick, tick, you sure could. So that's step one, finding the midpoint. Now we're going to want to draw a line perpendicular to this side through that point. So we could use a protractor to make sure it's a nice 90-degree angle. I like to just use a Post-it note, or I have this thank you card, because I know that this is a nice 90-degree corner. I'm going to line that up right at the midpoint. And then I should just be able to trace. I might extend that down a little bit because that bisector is technically a line. And that's our first perpendicular bisector. I'll mark that as a little 90-degree angle. For some reason, I find it easier to do the other sides if each side is horizontal, so I'm going to try that. So again, I need to find the midpoint. Looks like 6 centimeters this time, so my midpoint would be at 3 centimeters. If you'd like to mark those two pieces congruent, since that's the midpoint. So I've got the bisector ready. Now I'm going to make the perpendicular using the corner of my card. There we've got another perpendicular bisector. We've got one left, that top side of the triangle. Again, I like to turn my paper so I can see that as my base. Step one, measure. I'm seeing 9.6 this time. 9.6 divided by 2 is 4.8. So my midpoint would be right here. I could mark that as the midpoint by putting the ticks right here. And finally, we need our perpendicular. That was our final perpendicular bisector. Here's a chance to find out how precise you were. Do your 3 perpendicular bisectors all concur at the same point? The closer it is to all meeting at the same point, the more accurately you must have measured and drawn those. So here is my circumcenter. Now this part is optional, but if you'd like to try to draw that circumscribed circle, just make sure that you're planting that pointy part at the circumcenter. You'll reach the pencil out to the vertex, and since that circumcenter is the same distance to each vertex, this should work nicely to draw a circle all the way around that triangle. Not too bad. What that's supposed to show is that each vertex is a point on that circle, the circumscribed circle. So now your assignment would be to try the same thing on these 2 triangles. Again, each time we're going to measure, getting about 8.2, divide by 2 to find the midpoint, and draw a perpendicular. You'll want to make sure that you make those perpendicular bisectors nice and long, because on this obtuse triangle you might find that your circumcenter, the place where those 3 perpendicular bisectors meet, might not even be inside of the triangle. So go ahead and continue. Find your midpoint, draw your perpendicular. Find your midpoint, draw your perpendicular. And somewhere all 3 of those lines should meet. And I want you to do the same thing on this right triangle. We have a nice example of an acute, an obtuse, and a right triangle, just to see how those perpendicular bisectors act on different types of triangles. So again, finding the midpoint, drawing the perpendicular. Midpoint, perpendicular. 3 perpendicular bisectors on each of these, and then see how close you can get to having those 3 meet at the same point the point of concurrency, the circumcenter.